Write 1 triple equals 1.0 in JavaScript and you get true. Run the exact same code in PHP and you get false. Paste it into Swift and your build fails to compile. 3 languages, the exact same characters, 3 completely different outcomes. None of these languages is broken and none of them is wrong. The reason they disagree turns out to be a lot more interesting than a simple comparison operator. Start with JavaScript. JavaScript's triple equals asks a single fundamental question. Are these the same numeric value? When you write 1 triple equals 1.0, JavaScript says true because every JavaScript number value is specified as an IEEE 754 double precision floating point value. To JavaScript, literal 1 and literal 1.0 evaluate to the exact same double precision value. You didn't write 2 different numbers, you wrote the same number twice. Under the hood, engines like V8 optimize this using an internal representation called Smi, small integers, to avoid heap allocation where possible. But conceptually, JavaScript only cares about the number.
Notice how ECMAScript intentionally defines triple equals differently from IEEE 754 equality for edge cases. For instance, triple equals treats +0 and -0 as equal, but treats nan as not equal to itself, which is why JavaScript also gives us Object.is for strict value identity. PHP looks like it should agree with JavaScript, but PHP asks a second question. Are these the same type and the same value? In PHP, 1 is an integer and 1.0 is a float. PHP stores values in a runtime structure called a zval. When triple equals runs, Zend first checks whether the stored types match before comparing the underlying values. Because integer does not match float, the comparison stops immediately.
The operator didn't change between JavaScript and PHP. The rule is virtually identical. What changed is that PHP treats scalar types as distinct boundaries. This distinction matters. Historically, PHP's loose double equals tried to be helpful by coercing types, which contributed to real-world authentication bugs involving so-called magic hashes, where string values like 0E1234 were loosely compared as numbers. Swift takes a radically different path because Swift's triple equals isn't asking about values at all. Swift asks, are these the exact same object in memory? That's identity, not equality. Because of that, Swift's triple equals only operates on reference types, classes that conform to any object.
If variable A and variable B reference the exact same object instance on the heap, A triple equals B is true. If variable C is a separate instance, A triple equals C is false, even if C contains identical data, which is why 1 triple equals 1.0 in Swift isn't false, it refuses to compile. Int and double are value types rather than reference types. Asking whether 2 value types share an object identity is semantically meaningless, so Swift's compiler stops you before your code ever runs. Notice what happened to point 0 across all 3. In JavaScript, point 0 evaluated to the exact same number. In PHP, point 0 changed the scalar type and failed to check. In Swift, point 0 is irrelevant because value types don't have object identity. So why would 3 languages take the same 3 characters and point them at different questions? Because they were built for different jobs, and equal changes meaning depending on what you're building. JavaScript prioritized flexibility for web pages. PHP prioritized explicit script types for web servers. Swift prioritized strict type safety and memory safety for applications. Other languages made their own trade-offs. Python skipped the symbol entirely and used the is keyword for identity. CPython caches many small integers, typically -5 through 256, but identity behavior outside that range is an implementation detail and should never be relied upon. Java went the other way, assigning double equals to reference identity for objects, leaving generations of developers wondering why new string A double equals new string A evaluates to false. This reveals the real takeaway. A web browser language, a server language, and a systems language couldn't agree on what it means for 2 things to be equal, and all 3 were right for their own reasons. The rule isn't triple equals means strict equality. The rule is find out what your language thinks same means, because it almost certainly isn't what the last one thought.